Okay, so now how to place and show dimensions legibly. These are some rules for you. In this particular case, what we have is these three dimensions. Um, you don't put the dimensions straight up on top of each other. What you try to do is stagger the dimensions within the dimension lines, and that makes for a more readable drawing. Um, in this case, we have two different ways to do this. What we have is a crosshatch from a section here, and then that section we have to dimension this 12 millimeters. Okay, the best way to do that is to have two extension lines and then the 12. In this case, what we did, this is okay. What we've done is interrupted the hatching when we put the 12 millimeters in the object. But this is definitely wrong here, where we did not interrupt the hatches when we put the 12 on the object. Now, this is an example here of some poor dimensioning. What we have is an object. These lines here, these dimensioning lines, appear on the object, and this dimension 12 and a half millimeters for the diameter of the circle, it's on the object too. Okay, so what we have done is we've moved all of these dimensions off of the object, and also the dimension for the hole size. Here's some more. This is good. What we've done here is we've measured the depth here from these lines. That is good. What we've done is we've taken a cross section of this feature here. Yeah, it's a poor practice to dimension to hidden lines like we're showing here. It's hard to see. And then you can see that this is a diameter, and also this is the diameter, so you can kind of see what this is. You can have an easier time picturing it. Here is a good one. In each dimension is given in the contour view. Okay, so what we're saying here is, hey, I'm looking at the hole here, and I'm pointing to that hole with my leader line, and it's telling me what my dimension is. Okay, so the hole and also this radius, you want to dimension those in the view where you can see the feature. So over here in this poor dimensioning, this 22 millimeter hole is pointed to in a phantom view. It's just not good. It's poor dimensioning. And like this R34, that's poor. So here it's much clearer if we're pointing to the hole, in the hole where we can see the hole is and it's round. Okay, contour view. That's very important. Here's another one, superfluous dimensions. All dimensions must be shown, but don't give unnecessary or superfluous dimensions. We also call this double dimensioning. In this example right up here, we have a hole, which is diameter 6.3 millimeters, and then this symbol is depth to 16 millimeters. So what that means is this hole is drilled to 16 millimeters deep. What we tried to do over here is to put a dimension on the depth. No, that's not right, because it's already dimensioned here. In this case, we have the width of the part, 12 millimeters, is dimensioned here, and it's dimensioned here too. As wrong. It's called double dimensioning. We don't want to dimension any feature more than once on a drawing. That's impossible. Now look at this one here. You got 1.24, and then you got 0.62 over here on this side. Okay, so 1.24 minus 0.62 is 0.62, so we don't need this dimension here. Okay, this dimension and this dimension are sufficient. If you put this dimension in it, you've actually overconstrained the part, and that's what we call double dimensioning. Okay, in this particular case, what they're doing is they're dimensioning the angle, and then this one dimensions the size. So you don't need this dimension, and that dimension. You only just need two of these dimensions. You just need this dimension here. look at, you can use this for repeated dimensions, okay? So in this particular case, we have a radius of a 1/2 inch, and we have 4 of them. So we can put 4x, our point of that 4x means the x means by, or 2, by. So 4x means 4 times. 4 times point. Okay, so, and then in this case, we have a 2 by 1/2 inch radius. And in this one, we put a 1/2 inch radius there. That's not right. And in this case here, the width of this part is defined by this 1 inch diameter across here. Okay, not this 1 inch over here. So be careful. I've got one more slide on superfluous dimensions. Okay, so in this case, we have this dimension which locates the center of this arc, and then we have the arc length. If we have these 2 dimensions, we don't need this overall dimension. And it's the same for this one over here. If my radius is 0.88 and this is a full radius, and then this 1.76 is a double dimension. Okay, so this one here is superfluous. We've got the diameter. We don't need to show the diameter here. In this case, we have a threaded hole. So we don't need to say what the diameter of the threaded hole is. The diameter is specified into the thread call out. This one right here, okay, we have this overall length dimension, and then we have a radius. If we have this one and this one, it tells us what this dimension is. Okay, or if we had this dimension and this dimension, then we don't need this one. That's called double dimensioning. So again, be very careful when you're creating your drawings not to have superfluous or double dimensions. It's very important. I will take points for those things. Dimensioning angles. These are all examples of how to dimension an angle. In this case, we have one leg and an angle. Okay. In this case, we have the length of both legs. Okay. That's 2 different ways to dimension a angle. So how to dimension arcs, fillets, and rounds? One way to do it, if you have a part that has a lot of rounds on it, is to put a drawing note that says fillets R6 and rounds R3 unless otherwise specified. Okay, or all casting radii R6 unless otherwise, or all fillets and rounds R6. So if you use a note like this, you don't have to identify each and every round and fillet on your drawing and then put a dimension on it. It's going to be very important when we put dimensions on drawings, and I'm going to mark you for this, is that all dimensions have to appear on the drawings. You can't miss any of them. So if you have a lot of rounds and a lot of fillets on your part, please use a note that says rounds or fillets. Okay, now how to dimension sizes in a cylinder. Okay, so cylindrical features are round, so we always use the diametrical symbol to indicate a circular shape. So cylinders are usually dimensioned by giving the diameter and the length where the cylinder appears as a rectangle. Okay, so in this case, we have this diameter and we have this other diameter. What we're missing is the length, the thickness of this cylinder. Okay, in this particular case, use the diameter symbol to indicate the circular view. Okay, so each one of these cases, these are diameters, and then these are the lengths. Okay, size dimensioning holes. I'm going to stop here. We're going to have one more movie in this lesson. Thank you.